Hi, welcome to your Algebra 2 Lesson 5.2. Today we're going to talk about how to evaluate and graph polynomial functions. So that's the objective. So what is a polynomial? Just to remind you, you've covered some of this before in Algebra 1. A polynomial is a monomial or a sum of monomials. A polynomial function is a function of the form f of x equals an x to the n plus an minus 1 times x to the n minus 1 plus on and on and on until you get a1 times x plus a0. So one thing you need to notice is that when they are in standard form, you go from the largest power of x to the smallest power of x, which is your constant value. Okay? Where an is not equal to 0, the exponents are all whole numbers and the coefficients are all real numbers. So you have to have real number coefficients and you have to have whole numbers for your exponents. An is called the leading coefficient. The whole thing here, an times x to the n, is the leading term. An is the leading coefficient, n is the degree, and a0 is the constant term. And again, a polynomial function is in standard form if its terms are written in descending order of exponents from left to right. So in other words, they get smaller as you move on going from left to right. So here are some common types of polynomial functions. If it's a degree of 0, if you just have f of x equals 4, that's a constant function. If you have f of x equals 2x plus 3, the degree would be 1 and it's linear. If the degree is 2, it's quadratic. If it's a degree of 3, it's cubic. And if it's a degree of 4, it's quartic. We're going to use direct substitution to evaluate f of x equals 2x to the fourth minus 5x cubed minus 4x plus 8. So we've got a polynomial function, and we're going to evaluate it when x is 3. Our polynomial function is in standard form. So just for the sake of talking about it, this is a degree 4 polynomial. Okay? It's got a leading coefficient of 2. It's a nice positive number there. So direct substitution is just the substitution that you've used before. We're going to evaluate. Evaluate means substitute and simplify. So we're going to take 3 and put it in everywhere we see x. So the way that we write it is f of 3. That just means we've plugged in 3 for x equals 2 times 3 to the fourth minus 5 times 3 cubed minus 4 times 3 plus 8. I want you to always show the substitution step. That way I know that you know what you're supposed to do, even if you make a mistake actually executing it and your arithmetic goes awry from here. At least I can give you partial credit for knowing to plug in the 3 everywhere you see x. Now, another reminder here, remember f of x just means y. F of 3 is just telling us that we plugged in 3 for x. You don't have to do anything with this 3 over here on the left-hand side. It's just telling us what we plugged in for x. All right, we do want to evaluate the powers and then multiply. So 3 to the fourth is 81. 3 cubed is 27. Plain old 3 is just 3. So let's see, 2 times 81 is 162. And then minus 5 times 27 is 135. And then 4 times 3 is 12, so we've got a minus 12, and then plus 8. We just want to add and subtract as called for there, and we end up with 23. So f of 3 is 23. The function f in this problem, when you plug in 3 for x, is equal to 23. If we were looking at ordered pairs, the ordered pair 3, 23 would be on this function. Now, there is something called synthetic substitution, especially back before people had calculators readily available to them. This was just another way of evaluating a polynomial that kept you from having to raise numbers up to large powers. And so sometimes it makes the arithmetic a little simpler. So let's look at it in an example. All right, we're going to use synthetic substitution to evaluate f of x from example 2, or actually for us it's example 1, when x equals 3. So we've got f of x is the same problem, equals 2x to the fourth minus 5x cubed minus 4x plus 8. Okay, the way you do this is you're going to write the coefficients of f of x in order of descending exponents. So if it's in standard form, you just write the coefficients. Okay, you're going to make a little table thing like this. You're going to skip a line right here. Okay, you're going to leave some room for work. you put the value for which f of x is being evaluated to the left. So over here, you make a little line going down. You put whatever x is. So x is 3, so that goes right there. And then you're going to have 2, -5, 0. Why is 0? Well, because there's no x squared term, and you have to hold its spot. Okay, you have to. There's no option about it. You have to, if a degree is skipped, see how this goes from a degree of 3 to an understood exponent of 1, there's no x squared, you have to hold its spot with the 0. And then -4, and then 8. Okay, so you've got your coefficients here. All right, so what we do is you always just bring down the 2, okay? Bring down the leading coefficient just down here, and then you start multiplying. You take the leading coefficient and you multiply by the x value. So you're going to do 2 times 3 is 6, and then you add down the column. -5 plus 6 is 1. Whatever number you have down here on the bottom then gets multiplied by the leading by the x value, the 3. So 1 gets multiplied by 3, and it's going to go underneath the 0. Okay, it's going to go underneath the 0, and then you do 0 plus 3 is 3, and then you do 3 times 3 is 9, and you write it here. -4 plus 9 is 5. 5 times 3 is 15. 8 plus 15 is 23. And this little guy over here is our function value. F of 3 is 23. And we never had to raise 3 to any big power. So synthetic substitution gives us the same example, which matches our previous result. And so you need to be able to simplify it using both methods. Okay, you will be told which method to use, and you need to be able to use both. Okay, end behavior. The end behavior of a function's graph is the behavior as the graph of x approaches positive infinity, goes far to the far right, or negative infinity, the graph goes to the far left. And you need to write this little chart down. You're going to have to know this, and it will make more sense in a second whenever we look at some pictures. So, the end behavior of polynomial functions all depends on the leading term, the a to the n times x to the n. You're going to be looking at two things. You're going to be looking at whether n is odd or n is even, and then you're going to be looking at whether or not you have a positive or negative coefficient there. Okay, so if an is greater than 0, if it's positive and n is odd, then your function is going to go really far down as you go to the left. And the way we write that algebraically is f of x goes to negative infinity, that means really far down, as x goes to negative infinity, and that means far to the left. And f of x is going to go to positive infinity, it's going to go way up high, as x goes to positive infinity, as x goes to the right. Now you need to be really careful that you've put the correct signs here in your notes. All right, so if an is less than 0, if we have a negative leading coefficient and n is odd, then f of x goes to positive infinity as x goes to negative infinity. So in English, that means f of x is going to go up high as x goes to the left, goes far to the left. And f of x goes to negative infinity as x goes to positive infinity. So as we go to the right, f of x will go really far down. Now, one thing I want you to notice is that we always have a left side and a right side. We have a left end and a right end. The question is, what is the function going to do? Okay, so we've talked about having odd degree, things like 1 or 3 or 5. What about even degrees? If we've got 2 or 4 or 6, well, if you have a positive leading coefficient, okay, an is greater than 0, it's positive, and n is even. It's just like when a was positive for quadratics. It looks like it's smiling at you. So on either end, to the left or to the right, the y values are going to go up really high. So f of x goes to positive infinity as x goes to negative infinity. So as you go to the left, the function is going to go up. And as you go far to the right, the function is also going to go up. So somewhere in the middle, it dips down. Okay, but as you go to the left, it goes up. As you go to the right, it goes up. If you have a negative leading term, just like when a was negative when you had a quadratic, and n is even, then your overall function is going to look like it's frowning at you. F of x is going to go really far down. Y is going to go really far down toward negative infinity as x goes to negative infinity. So as you go to the left, the function is going to go down. And f of x is going to go really far down as x goes to the right. Okay. Now, all kinds of stuff can happen in the middle. Okay. But this is what happens on the ends. And really, it helps me to see a picture of it. So here are our two big cases. Okay. And then within each big case, there are two small cases. So p has an odd degree, p has an even degree. So we're talking about like x to the first, x cubed, x to the fifth. On that one, you're going to have your ends going in two different directions. One end is going to go up and one end is going to go down. Okay, so when you have a positive leading coefficient, it's going to go up as you go to the right. So y goes to positive infinity as x goes to positive infinity, and then the opposite is going to happen as you go to the left. As x goes to negative infinity, as we go far to the left, y is going to go to negative infinity. All right. If you have a negative leading coefficient, you're going to have the opposite case. You're going to have y going up, 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 up as you go to the far left. So that means y goes to positive infinity as x goes to negative infinity. And then as x goes to positive infinity, y is going to go negative infinity. It's going to go down, down, down. Now, just like with quadratics, any kind of even degree, so if it's x to the fourth, x to the sixth, just like with x squared, if the leading coefficient is positive, overall it's going to look like it's smiling at you. Now, it might have a wiggle in the middle, but y is going to go to positive infinity as we go to the far left, and y is going to go to positive infinity as we go to the far right. If it's got a negative leading coefficient, it's going to look like it's frowning at you overall. So both ends, both the left end and the right end, y is going to go to negative infinity. All right, so what is true about the degree and leading coefficient of the polynomial function whose graph is shown? Well, first thing we can tell is since the two ends are going in the same direction, they're even. That means the degree is even. Degree's even. Overall, it looks like it's kind of frowning at us, and so that means you have a negative leading coefficient. So the answer is going to be D. So let's look. So from the graph, you can see, if you don't remember it that way, you can always do it more analytically. F of x goes to negative infinity as x goes to negative infinity, and f of x goes to negative infinity as x goes to positive infinity. So the degree is even and the leading coefficient is negative. So D, again, is the correct answer. So graphing polynomial functions. To graph a polynomial function, first plot points to determine the shape of the graph's middle portion. Okay, starting at -3 and going to +3 using integers usually gives you a pretty good sketch of what's going on, and that's really what we're doing here. And then use what you know about end behavior to sketch the ends of the graph. So we're going to make a little table for each one of these where you let x equal the integers from -3 to +3, and then you evaluate. Now, you can use direct substitution or you can use synthetic substitution. I don't care which when it comes to this, but when we plug in -3 into x, where f of x is negative x cubed plus x squared plus 3x minus 3, we generate a function value or y value of 24. When you plug in -2 and you shoot it through the function, you end up with 3. -1 gives you -4, 0 gives you -3, and so on. And so what you do is you plot these points, okay? And so -324 would be way over here, so maybe if it's a crazy point like that, you don't worry about it so much. But here's our -2, 3, -1, 4, 0, -3, 1, 0, 2, -1. Okay, and you just sketch what you've got here. All right, and then we look at it and we go, okay, it has an odd degree, so we expect our ends to go in two different directions. We have a negative coefficient, so that would mean it goes up as we go to the left, and it goes down as we go to the right, and that's what we have here. So you just finish it. And plus, the points are kind of hinting at that that's what you should do, and certainly our pattern backs it up. All right, so here we go. We've got, we're going to do the same thing with our second function, f of x equals 5x to the fourth minus x cubed minus 4x squared plus 4. So we're going to evaluate for x equals -3 to 3 using the integers. So when you plug in -3, you get 76. Well, I don't expect you to draw a graph big enough to do the 76, but we can go, okay, that's going to be way up here. Okay, we get that. -2 is going to be 12. Well, you might not even have room on your graph to do that. Negative, but we know that means that it's coming in like so. And then there's -1, 2, 0, 4, 1, 0, 2, -4, and then 3, 22 is going to be way up there. So we know that between 2 and 3, it's got to cross the x-axis, because to get from -4 all the way up to 22, you got to cross that x-axis. Okay? So let's look back at the function itself, and remember, you're just taking these x values and plugging them in. We have f of x equals 5x to the fourth minus x cubed minus 4x squared plus 4. So it's x to the fourth, so it acts like x squared. The two ends are even. They're either both going to be going up or both going down. Since we have a positive leading coefficient, 5, just like with a quadratic looking like it's smiling at you, this one's going to look like it's smiling at you. Now, it may have some wiggles in the middle, but it's going to look like it's smiling at you. And sure enough, here it's like a really weird smile, but it is looking like it's smiling at you. Both ends are headed up. Okay, go ahead and try the problems to try on your own. Again, if you cannot do the problems to try on your own, go back and watch other parts of the video, come in and see me, but remember, to get full credit for your notes, you have to have those printed by the time you get to class. So make sure you do that, because I want you to get full credit. Thank you for watching the video and taking good notes. I hope you have a great day, and I will see you soon.